Absolutely honored to be joined by Dr. Ritu Raman. Ritu, thank you so much for joining us today.
Thank you for having me. I'm really excited to chat with you.
I have to ask you just, off the start, and you probably get this a lot, but particularly for those who might be new to this entire concept. But um, for those who are brand new to the field or for the concept of this, how do you describe biofabrication in a nutshell, so that people can really digest this?
Yeah, I mean it's quite a mouthful of a word, so always worth a definition, I think. I would start by saying, typically when people think of engineers, you might think of folks that are building machine systems, right? So they're building a table, they're building a train, and they're typically using metals and polymers and ceramics and those kind of materials that we're typically seeing in our built environment. So the way I describe biofabrication is to think about engineers building with biological materials like living cells or proteins. And I think that's the way that a lot of different people I think that's the way that a lot of different people define that word.
And was this for you particularly, as someone who's trained, in mechanical engineering through and through? Was this a particular pivot that you had to make in your sort of journey through this as well?
Yeah, definitely. I think, when I started out as a mechanical engineer, I come from a family of engineers, and I thought I had a very specific idea of the kinds of things that engineers build and the kinds of materials they use. And I was very comfortable with that. And certainly I went to Cornell for undergrad, and a lot of different classes that I took, we were building with materials like metals and woods. And that's what made the most sense for a lot of the stuff we were making. However, I was an international student. At the time I was at Cornell. And for those listeners of your podcast who are international students, you know that it can be very hard to find internships in relevant fields. Particularly at that time, I was looking, in the aerospace industry, and it was just like, that's not going to happen. So the
Right.
only volunteer position I could find was in a biology lab. I believe it was the summer after my sophomore year. And that internship was really exciting because I was working on a project that initially had no real relevance to my mechanical engineering training. I was
Mm.
working on helping them put rats on treadmills, essentially, to study how exercise changed muscle adaptation.
Yeah.
And it was kind of completely off target from what I was doing. But over the course of that internship, watching and thinking about how the muscle in the rats was dynamically adapting to the external stimulation of exercise was very exciting. And I started thinking about biological systems and materials more as materials, like things that could sense and adapt to their environments in real time in a way that synthetic materials can't. And I think that experience was really pivotal, and changed kind of my view of what types of materials engineers can build with.
Yeah. When someone hears that story and then kind of fast forwards to your work today from those initial experiences, at least from the academic side, when you're describing both the definition of biofabrication and maybe a little bit about your work to people who aren't in the field or even non-academics, how much of that chatting is taking up energy and time, that you have to spend in a way kind of demystifying, or for that matter, untethering it from those sort of popular science fiction pieces, because certainly for those who are unfamiliar with the field, and for that matter not in academics, must have plenty of questions about what that actually means, both in the lab but then also in real world application.
Yeah, I think that that's something that, anytime you're kind of doing research at the cutting edge of a new scientific discipline, a lot of your energy gets spent not only in doing the work, of course, which is very hard, but in convincing people that it's worth doing and explaining kind of the premise of this idea and the basic words that you're using, like biofabrication. So
Yeah.
we do spend a lot of effort trying to convince not only the lay public, but also funders and publishers, what are the words we're using, what are the machines we're trying to build, and why are we trying to do this? But I don't know if that's necessarily unique to our work, or maybe
Mm.
just a general sense of any time you're running a research lab, you are doing science that hasn't been done before. And so explaining it is kind of part of the deal that you signed up for. Related to your second question, though, I think one of the things that makes my job easier is that a lot of science fiction has explored these type of concepts of building, replacing tissues inside the body with like living tissue mimics, or building robots that have biological components. There's a ton of stuff actually in the literature, superhero, sci-fi, that covers this. So I think people have a lot of sort of excitement about it and sort of general literacy with the ideas. I gave a talk last week to about 500 high school students that were part of a summer camp at MIT Lincoln Lab. And I got a ton of questions after the talk that were really, really thoughtful and very aligned with our research. And I was like, man, people just get it right away. And I think it's because these ideas are kind of, everywhere in our culture already.
I heard you talk once about how, what's the actual perhaps biofabrication models behind the flash, and
Mm-hmm.
like, how that speed actually happens from a muscular standpoint. And I mean, I think more than anything else, it probably gets the public to be curious, and certainly link it back to something that they can relate in pop culture or in their daily lives. And yet, I even would beg that, with all that being said, and this blend of academics and kind of popular culture and curiosities, even from high school students, how far are we from actually directing our robots to go to the gym and to make their muscles stronger, or to get massages for those muscles and joints that need replenishing and restoring?
Yeah. So I can tell you maybe how far we are in the lab and make a little bit of a prediction maybe in where we can go. So in the lab, what we've done from the robotics standpoint is made muscle tissues from mouse cells and also from human cells in a petri dish environment. And we've shown that we can get them to generate force and produce motion. We can exercise them to make them stronger. We can damage them and watch them heal in response to that damage. But all of that happens in the environment of a petri dish, right? So it's very controlled, it's sterile, the temperature and humidity is regulated, and that's very different from the environment that you might want a robot to function in. So to really deploy these muscles as functional components of a robot, we would need to find ways to essentially develop like synthetic skins and other support systems that could keep the muscles healthy and warm and protected from their environment. That I think will take us probably another decade or so. But perhaps in my lifetime, we could start seeing some real world like robotic applications of the robots. From a medical standpoint, what we've shown in the lab is that you can implant the muscle that we engineer in a petri dish in a mouse. And then that muscle can integrate with the surrounding host tissue in the mouse and help restore mobility after traumatic injury. To be able to do that in a human being, there's a variety of regulatory considerations,
Right.
which I'm sure you're very aware of. But, it's a question of like, how do we get billions of human muscle cells from the person, from the donor, where we'd want to implant the tissue eventually? How do we grow them up? How do we make those tissues? And then how do we kind of scale this up in a way that it can be deployed as a safe therapy. That also I would anticipate. I mean, there's a lot of cell therapies that have had great success in the clinic over the past few years. So I think there's a roadmap for doing a tissue therapy like this.
Sure.
But I think also in a couple decades, we'll start seeing tissue therapies, not only in the context of muscle, but also other things like skin and liver.
Yeah, amazing, right? I mean, like the medical possibilities and the idea of how this helps people heal, and whether there, such a myriad of different reasons why the necessity is there. Definitely the idea of robots getting gym memberships are perhaps a little bit further or a little bit different in scope. But in reflecting upon a lot of this, right? I mean, your first experience was in that as a volunteer in a lab, but now that you're, perspective has evolved and you have really had a terrific not only just foundation, but you're really at the forefront, or you have a front seat to this activity so much. In reflecting on some of the experiences that you've had growing up, and even as someone who's been in a variety of different life experiences, when do you actually first remember, in retrospect, actually thinking and understanding that, hey, these were touch points or moments in my life where I've actually interfaced with this concept of biofabrication?
Mhm. Oh, that's a very interesting question. I mean, I think I would say that so I moved around a lot growing up. I grew up in India and Kenya and all over the US. But some of my first memories are in Kenya. And when my parents and I were there, we did a lot of work, or not me, I didn't do anything. I was a toddler. But
Yeah,
my parents did a lot of work in rural parts of Kenya. And we lived in a city and we would travel to the rural parts over the weekends. And when I was there, I mean, it's a phenomenally beautiful country. The geography is beautiful. The plants are very diverse. And of course, the animal diversity in Africa generally and East Africa specifically, like you get to go on safari when you're 5 years old. It's
right.
always exciting, but I think it's like particularly exciting when you're a child and you don't realize how unusual of an experience that is. So I think I had a very early exposure to sort of the beauty and diversity of the natural world, and that was always very exciting to me. But and then, the concept of being a scientist, I think, was not a super specific idea that I had. Like, I wanted
Sure.
to do a lot of things. I wanted to be an athlete and a musician and all these things. But I do remember very specifically telling my mom at one point, and she brings this up all the time, that we watched a documentary where folks were working with plants in a lab environment, and they were wearing these really crisp lab coats and like manipulating these plants. And I was like, that I really want to wear this lab coat and like, you know,
Yeah,
have a lab and like
yeah,
do cool, crazy science kind of in a sci-fi sense. So
of
those are kind
course.
of the earliest touch points I can remember. But I would say you can pick and choose data points. There's probably many other things that I did during my childhood that could have pushed me in another direction. But I
Yeah.
really think that research experience was one of the more obvious and thoughtful changes that I made towards doing biofabrication as a job.
I wonder if, being in those settings, also you talk a lot about, adaptation and resilience,
Mm-hmm.
and the idea that biofabrication, the motivation behind it is such that, these um, vehicles and these models and these tools are trying to adapt in the same way that, our sort of biology does. And I guess, is that sort of a proxy for who you are? In general? Are you someone who also equally is, the work is easier simply because, that's how you function in a lot of ways, or that's how your sort of temperament or your nature is?
Definitely. I actually think about that theme a lot. I think between my personality and the kind of research that's very interesting. I mean, I think most people are understandably very frightened of change. And I think particularly children, because a lot of children tend to hopefully have relatively stable lives and they like go to school and they have the thing and they're in one place. And the ideal world, right? The kind of world that my mom, for example, grew up in is she went to kindergarten with the same people she graduated high school
Right.
from, and the same thing for my husband. And I think just based on, a variety of different things that happened in my childhood, I went to 10 different schools by the time I graduated high school. And what that teaches you is that change is something you can handle and you can like learn a lot of new things. You can meet new people, you can explore new places, and you can sort of dynamically sense what's going on in any environment and not change your personality, but sort of adapt things that you're doing to be able to better thrive in that setting. So
Mm.
I think that gave me a lot of comfort, just, acclimatizing to new places and thinking about change as generally a good thing and something we can learn from. And I think that's not only useful in the context of biofabrication, but just as a scientist, a lot of what you do when you're an experimental scientist is do experiments that don't work, like
Right.
99.9% of the time. So being able to bounce back quickly from disappointments is, I think, very important. And learning that skill as an adult is very hard. So
Mm.
I would hate to be like, I don't want children to experience hardships necessarily, but if there's some setbacks you can experience in your childhood that are sort of small and contained and give you a chance to adapt and grow from that, I think it can be a very good thing.
I'm curious in that same way where, it's important and it's in fact an elegant thing, particularly as a parent, but certainly when you're a child or when you're reflecting back on childhood that, where setbacks are actually important learning lessons, and how to actually make the work more adaptable, how you make yourself more adaptable to the work and with the work and have a relationship with the work. Um, when you think about biofabrication as a discipline,
Mhm.
is is the goal to duplicate, and these might be naive questions, but is the goal to duplicate? Is it to integrate, or is it to exceed, or is it actually all of those things?
That's a great question also. I think it really depends on the application. So in the case of I'm making a tissue that I want to implant in a person, or I'm making a tissue that I want to use to screen a potential therapeutic drug that I might want to eventually give a person, there I think the goal is to duplicate as closely as possible not only what is happening in human physiology, but what is happening perhaps in that specific patient. Um, in the case of robots, there are many times you might want to, say, use muscle as an actuator, but you might want to be able, muscle in our bodies, it gets a pulse from a neuron, and that neuron is a short amount of time. It fires for, a few milliseconds. But we've shown if we keep that electrical pulse input to our muscle on for longer, then the muscle will stay contracted for a little bit longer. That's not how our body solves that problem. That's not what's done in physiology. But in a robot where you want to be able to, say, hold something for a little bit of time and then release it, this sort of control strategy works really well.
Yeah,
So that's a situation where you're perhaps exceeding or doing something different than how you would do it in a natural biological system. And it's just because you'd want that in a robot, but you wouldn't want that in a person.
right. Yeah, no, that's so wonderfully said. And if you think about that, then of course it gets tethered to so many extra, important questions that surround those conversations as well. And when in reading the book, I just fascinated by the possibilities of things and the optimism around different ideas, and of course that's what piques people's interest. But there's also a really important needle that you thread to carefully note all the ethical boundaries and the
Mm-hmm.
sort of parameters and the guide wires with which you do the work. Um, is it important to find that sort of ongoing harmony between the power of possibility and those kind of proximities to those precipices that we should really, really be mindful of? And as you, by the way, engaged more and matured more and developed more as a scientist, as an academician, do those become that much more obvious on a day-to-day basis?
Hmm. Yeah, I mean, I think actually going back to what we started off the conversation kind of talking about sci-fi, right? And
Yeah,
superhero movies. Most of the time, yes, we have these beautiful examples in these movies of like cool things that can be done with science, but often, and in fact, nearly always, um, it's kind of negative, right? Like the
mm,
science seems cool, but then it goes too far, and the scientists didn't think about the consequences of their work, right?
right.
Or it's a futuristic world, but it's dystopian in some way. And I'm glad you picked up on the optimistic tone of the book, because I think I am a very optimistic person in general. And I think most scientists are, because the whole
Right.
premise of the job is there is a challenge in our world, and we're gonna do some science, and we're gonna solve that challenge. We're gonna
Right.
make people feel better.
Yeah.
And I think it's really important then to not only train our engineers, but also to talk to folks who are not scientists or engineers in the lay public about how we think about why we're doing what we're doing, and the potential impacts it could have. I think a lot of engineers do actually think very consciously and thoughtfully about why they're taking a certain approach to something. Is it safe? Is this something I would want to put in a person? Are there potential unintentional consequences, particularly when you're building with biological materials like we do, because they're constantly sensing and adapting to their surroundings, thinking about
Yeah.
this is what that system is today, the day I built it, but how is it looking a week from now or 2 weeks from now?
Sure.
That's something that, I think we need to particularly emphasize. And I try to do it in our lab and in our educational training as well. But we also, I think, need to do a better job of building trust with the broader public. Because again, in a lot of these movies, it's like the scientists are just so indiscriminate. They're just like doing these
Right.
things without thinking at all about other
Yeah.
people. And I don't think that's true of most scientists. So I think engaging more scientists to talk to folks outside of their direct professional community about the work they're doing and getting some feedback on it and really listening to that feedback. I think that's a very important thing to do.
Do you think that takes practice? I mean, because that doesn't necessarily come naturally to everyone. And is that something that you've had to not only just be mindful of in the lab, but certainly be thoughtful of when you're thinking of that optimism and how to, in a way, kind of temper that, but in a optimistic way?
Yeah, there's two parts of that take practice. I think one part is anytime you're explaining your science, you have to have a lot of empathy for the person you're talking to and understand their training and the way they're perceiving what you're saying. So if I'm talking to an MIT graduate student versus I'm talking to a high school student that's visiting the lab versus I'm talking to my grandmother, those are very different types of conversations. And it's coming from a place of like, what does that person know? What are they excited about? So I think that's a big part of the training that we do, is making sure that every time, just yesterday, I talked to a graduate student who wrote this really interesting proposal idea for their research, but kind of wrote it in the sense that like, if anyone in our lab read it, they'd be like, awesome, I get it, I would understand. And if anyone who's not familiar with our lab read it, they'd be a little confused, right? So I had this conversation with her about really think about your audience and tell a story that makes sense to other people without thinking about it as dumbing it down. It's just like telling the story in a way that makes sense to a different human. The second part that's hard, I think, about these conversations is just a broader societal hardship, which is that it's very hard to hear feedback on your work. And somebody's instinctive and initial response to what you're doing might be that it's not that interesting, or they find it scary, or they don't like it in some way. And your natural response to that might be, shut up. I don't want to argue. I don't want to have this conversation. And that definitely takes practice. I think one of the things that's helped me most in that domain is realizing that it's less important to win an argument and more important to win over a person, right? And so if you really like and respect a person and they really like and respect you, even if you initially disagree, you can continue to have a respectful conversation about a topic and perhaps achieve some mutual ground. But your motivation should not be to change their mind. It should be, this is a person that I like and respect and I'm talking to them. So I think getting that practice maybe with family and friends first might be a little helpful, where you have a baseline amount of love and trust so you can engage. And then if you're feeling more brave and empowered after that, you can start having these more difficult conversations outside of your immediate circle.
It leads me to think about like, how do you, in fact, lead with empathy and yet not lose sight of the problem you're trying to solve? And how do you communicate the right way? Exactly as you were just saying. That the example that I was thinking of was, someone who comes up with an amazing biofabrication idea to have some robotic device, understand, have a warning system for, and in fact engage and stop a forest fire. And yet, while that research must be, and even the system to be able to do that must be amazing, could solve so many problems and save lives for that matter, is that completely against systems that exist in nature and controls that exist in nature. And yet that person might be like, oh my God, this is the best thing that I've ever done. I mean, I'm here to save, so much. Yeah, there's some real guardrails in that. And if you don't have those conversations with people who give you that feedback and willing to accept that feedback, that might be a really tough thing as a young scientist, even an experienced scientist, to hear. And so, have you had to also in the field of in any academic field, but particularly in doing this work, have you had to unlearn some things as a professional?
That is a very thoughtful question, and one I have not been asked before, so I have to give it some thought. Have I had to unlearn something? I mean, I think that one thing I've really had to decouple, and that comes up a lot of time in academia, is separating the content of what somebody is saying from the tone in which they say it. And that's actually probably useful outside of science too, but I'll give an example of most of the time when we're publishing scientific research, all the time. It has to be peer reviewed, and peer review, for many good reasons, is anonymous, right? Because it's protecting people who may be your colleagues, who you may have some power over, to be able to give you honest feedback on your work without you lashing back at them in some other way. So that makes sense. However, as we know from social media and the internet more broadly, is anonymity sort of strips people of politeness. It has happened to me. It has happened to other people where you sort of are just like saying stuff and you're not really doing all of the sort of niceification that you do when you're actually talking to a real human being. You kind of forget that. And so often we will get feedback on our papers where it's literally made me cry. I'm like, why would you write something this mean and this hurtful, not only to me, but to the very young graduate students in my lab who are like doing this for the first time, right? So one thing that I found very helpful, and actually I've been using ChatGPT a little bit to help with this, is to take the content of what is being said and have it just like, what would happen if this was just rewritten in a nicer way? And then I read it, and if I actually agree with what they're saying, and really they just said it in a very mean way, but they did have a good point, sometimes hearing it, you catch more, you catch more flies with honey kind of thing. Like just hearing it in a different tone helps me sort of accept it better. So I think getting that time and that space and separating content from tone is something that I've had to relearn, but I will say it's something I'm still working on. So I would not say that I'm proficient or good at it yet. And I certainly get very emotional about this sort of thing. But I think it's overall just a good life lesson to learn of, even when somebody says something in the meanest possible way, is there a grain of truth in what they're saying? And if so, is there something that you can learn from that and use to inform your work and improve it?
Yeah, I mean, if the world could be a lot less mean, but very at least intentional, and use all their feedback in a way that's going to be supportive and helpful, that's always kind of a great principle of mentorship, whether it's anonymous or not. When you think about those feedback loops and the iterations that are then required and to then proceed with the work, again, it's like a fire hose of different ideas and applications, and definitely some make the light of day, and others are sort of languishing in peer review, or they'll never make it out there. But how do you sort of prioritize the applications? Because again, in a field like this, it's so broad, and it's hard to concentrate vertically when horizontally there's just so many different lanes to possibly swim in.
Yeah. I will give maybe a scientific technical answer to how I prioritize, and then I will provide some caveats on sort of real life strategy as to how I prioritize.
Please, yes.
So in an ideal world of infinite resources, the way I would and try to prioritize in our lab is I kind of choose big fundamental challenges that, if solved, would be applicable to both our medical work and our robotics work. So something we're working on right now in the lab is we're very good at making muscle. We're less good at making muscle that's controlled by upstream motor neurons. It's very hard to get neurons to grow alongside muscle, to burrow deeply into the muscle, form functional connections, and be able to study that over a period of weeks or months. If we could do it, we could achieve more precise control of robots. But we could also study a broader scale of diseases that impact not only muscles, but also upstream nerves. So that's something where we can pick that challenge of innervation of muscle and know that regardless of how it sort of pans out or which application ends up being more interesting, that's something that's going to be sort of fundamentally valuable. So that's the technical way we choose problems. The strategy part of that is that labs are funded by grants. Grants are mostly from government institutions or foundations, and you just don't know what's going to be funded at any given time. The success rate is very low, and things change very dynamically. So part of the real way of how we do things then is you see what grants get funded, and then you pursue those applications. So that's the caveat.
Kind of simplified down. Definitely the technical aspect is there, but the simple, at least practical side is you're following the money.
Yes, that's right.
I saw one of your tweets that talked about getting rejected from 15 out of 16 PhD applications, to institutions. And now that your career and work has developed, you teach, you mentor, you lead. And by the way, congrats on your stamp work.
Oh, thank you.
My irises and pupils are thanking you already. I hope there's some great applications on the way, and thinking about those 2D geometry, models for contractile muscle. But when you have a great accomplishment like that, you have a publication that's out, a piece of work now that is really generating buzz. And this notion of the world is full of rejection and competition and hierarchy. What have you, in a way, learned, not just in a personal fashion, but as a professional mentor, as a leader in this space? Um, how have you learned to navigate sort of a very, very hierarchical and academically competitive world where you constantly have to remain motivated and you have to remain in a sort of even keeled, not get seduced by the super highs and not get really drowned by the super lows?
Mhm.
Are there personal strategies that you've learned in order to be able to really, succeed in a world like this?
Yeah, definitely. I mean, I think that all life in general, all jobs require some resilience. And academic science, because there is so much built in hierarchy and questioning and rejection built into your everyday, whether you're presenting a project for the first time, you're trying to publish something, everyone's constantly questioning and criticizing. That's how science gets done.
Yeah,
But it can beat down any human over time. And the successes, because they're few and far between, you need to, maybe it makes you happy for a second, but it's not going to necessarily ride you through, the
mm,
10 rejections or 100 rejections that follow. So it is definitely a very emotionally hard thing. And I think one thing that has helped me um, in particular is that I think my parents did a really good job of, when I was growing up, emphasizing process more than outcome. So I was always sort of patted on the back and got compliments for working really hard on something
mm,
rather than winning something.
yeah,
And I think that that was very helpful in sort of rooting my self-worth in, did I do my best, rather than did somebody decide that was worthy of an award. So I think that mindset, even if that's not something that you're raised with, it's something that you can sort of train yourself to think about and really think about, what do I have control over? Many situations, right, where only when you've been through it a few times can you say, yes, I only got into one graduate program. And when I was 20, I thought it was because I was stupid. And now that I'm 32, I realize that it's because applications are a stochastic process and it was not a
yeah,
reflection of my self-worth. But it's very easy to say that after you've already succeeded and become an MIT professor, right?
yeah,
So one thing in the context of mentoring then, I try to really strike a balance of telling people about these stories, but not dismissing the immediate sadness and stress that they're feeling right now, because
sure,
it's very easy. People do this all the time in life. You break up with somebody will say, oh, don't worry, your true love will find you. And is that really helpful to anyone in that moment? It's not, right? So it's better to say, that's really sad. I'm sorry. When you're feeling able to address this, we can talk about whether it's worth trying this again, because sometimes it's not worth doing something 10 times and getting the same outcome. And if you're going to try it again, what are we going to do to change productively and hope for a better outcome next time? So I think being really mindful of that and not necessarily telling people, oh, it's fine, you got rejected, that happened to me before. Like, that's not
right.
very helpful. So giving people sort of useful strategies for dealing with that stress, I think, can be
I
a
can
kind thing
I
to
can
do.
see how undergrads and the junior most people in your lab, including your grad students and your postdocs, must be thrilled to have conversations with you, because I think that really matters, right? I mean, you're not doing lip service, and yet you're providing ladders of trust that are based in empathy and experience, and certainly I'm imagining that helps your own process as well. Um, is this where the don't follow your passions kind of advice comes from, in a way?
Yeah, definitely. I say that all the time. And I think maybe it's intended to sound more provocative than it actually is.
Right.
But the general advice I tend to give young people when they're thinking about what work to do in the future is to not only think about what is interesting to them, but to also think about the practical considerations of, is this an actual career that I can have, that can give me the stability financially and in my personal life to build the life that I want to live, right? Most of the time when people say they're passionate about something, they mean that they tried a thing and it was very exciting for a little bit and they think they could do it forever. But most of the time when you're thinking about your life, people think, okay, this is the kind of house I would want to live in. This is the amount of hours I would want to work. Maybe if I want to have children, this is the number of children I would want to have. And so you are more than just your work, right? So you have a broader framework of things you're trying to build towards in a life you're trying to build. And the exact specific thing that you're passionate about when you're at any age might not be the way to achieve or build that life. So I tend to tell people, rather than picking a specific thing you think you're passionate about, think about a problem that you would be interested in solving. Climate change, for example, would be a very good one that I hope a lot of young people are interested in solving. There are many careers where you can have a positive impact on that field and feel that you're working on something very meaningful. And based on what you're good at, what sort of, careers you think you can do, what sort of college you think you can pay for, what your family can kind of help you navigate, then you can sort of pick a path that will help you solve that problem, rather than saying, one day when I was 14, I decided I was going to be a mechanical engineer, and then that's the only thing I'm allowed to do. Like nobody, I think, has that kind of clarity, or most people don't. So I think that can be very helpful, particularly for young people if they're not feeling super passionate about something, or they're not sure if their passion can translate to a career. Picking a problem that's important to you might be a more productive way of getting to that goal.
First up, I love that because there's an obvious creative tension that both flows and doesn't flow with the stereotypical Indian or South Asian parenting style. And then on top of that, I think it's important in a way because of some of the other things that you write and speak so passionately about, particularly about shared vocabulary and increasing literacy and democratizing and diversifying the foundational sort of education. And, it's specific to biofabrication, but for that matter, in any sort of STEM field. I'm curious about that aspect of things, particularly now with respect to biofabrication and mechanical engineering in general. Why is it so important for big institutions to be cognizant of this literacy and that shared vocabulary and that democratization? And particularly, why is this so important for women and those who are underrepresented in STEM?
Yeah. I think back in the day, when my parents were training as engineers, my dad was a mechanical engineer, my grandpa was a civil engineer, my mom was a chemical engineer. And there were very specific things that those different engineering disciplines did. And you kind of had a sense of what they were going to be like. Civil engineers, well, they build bridges, and chemical engineers build factories, and mechanical engineers work on oil rigs, and this is what they do, right? And now if you go on MIT's campus or any other campus, it's very hard to tell a mechanical engineering lab from a chemical engineering lab from a biological engineering lab. There's a ton of overlap. Most stuff is very interdisciplinary, and most stuff is defined less, I think, by the technology that's being developed and more like, oh, we're addressing a challenge in human health, or we're addressing a challenge in renewable energy. So with that framework in mind, then it can be very difficult if you're a teenager. I interact with a ton of folks that are freshmen, sophomores coming in for the first time, and they're very well informed about what engineers do and what the different classes are. But how could you possibly know at 14 or 15 what's a grand challenge that you want to work on? Or do you want to work on it as a chemie or a mechie or a civil engineer or something else? So part of what I am hoping and excited about doing in terms of literacy is give everyone sort of the same sense of words and vocabulary that they can work with, expose them to a lot of different ideas, maybe stuff they didn't come across in their more major specific classes. And that way you don't have to feel funneled very early into your career in making a decision that might have a long-reaching impact that you weren't prepared for. And I think that's particularly important, and I'm glad you mentioned it, for women and other folks who are not very well represented in engineering yet, because some disciplines in particular, mechanical engineering, for example, people are like trains or rockets or cars. And then we don't typically give young girls rockets and car toys to play with. And so then they seem like they're not interested in that because you taught them to not be interested in that. And then you also told them that that's what mechanical engineers do, which is not true. And
Right.
so then they come into school thinking, well, I don't want to be a mechie because I'm not interested in trains, right?
Yeah.
Trains are very cool. I don't know why anyone wouldn't be,
Yeah.
but my point being that I think then it's very important to capture the full diversity of what it actually means to be an engineer. What kinds of problems can you work on and why are they important to you? That's very important to share, especially with those who might feel less welcome in some spaces as compared to others.
I'll get you out of here on this. The one of the things that I valued so much from reading the book and in, getting to know your work a little bit is the just, waterfall of ideas that are out there. And that could be the notion of robotics, particularly in applications to medicine, in impact on climate change and lab-grown meats or other, important discoveries in agriculture. And then, of course, any of the kind of, organ on a chip models and how much impact that has. All these things for me, when I think about those ideas, they certainly are very joyful. And I'm just curious for you, as you think about the next 5 to 10 years, or even the breadth of your career, and even sort of like impact and legacy for yourself, um, what is it about biofabrication that brings you joy? What is it that sort of, really kind of has that sparkle or that tickle of joy that keeps you both motivated, but also really excited?
I think we are at a very unique time in history where I think for a long time, we kind of thought of biology as like you open the textbook and they say, this is the cell and this is how the cell looks and this is where the DNA is. And that's it. That's done. Right. And I
Right.
think when I was younger, I didn't realize how much of that was actually fairly recently discovered. And I also didn't realize how much of it was actually not a complete picture at all. And so we live in a really exciting time where engineering is progressing very quickly, but biology has progressed a lot in the past couple decades, understanding more about gene expression, having better imaging technologies, being able to do gene editing. All these things are so new, right? And so to live at a time when both of these disciplines are sort of converging means that you get to kind of get new ideas all the time, new tools all the time. There are many things we do in my lab today that I would have loved to do 10 years ago, but that cell line didn't exist or that tool didn't exist. And so one of the really exciting things about being a scientist that's in an institution like MIT is that there's always new tools coming in, new people, new labs that are starting, and you'll be able to try out some stuff that you didn't know was possible before. And I think the thing that keeps me really excited and joyful is that many of the things I'm working on right now, I mean, some of them are like, yes, I'm working in muscle. I was working in muscle 10 years ago. But most of the projects in my lab right now are not ideas I had even 2 years ago.
Right.
They're ideas I had because we talked to a bunch of people, students joined, they had their own ideas, and it sort of grows, right? And I'm hoping that in 5 to 10 years, we'll be working on stuff that I have not thought about or imagined right now. And I think that change and dynamism is very exciting and is what kind of keeps me really peppy and perky about the future of science.
Does that dynamism and does that change, especially when thinking about legacy and the things that you're going to be sort of noted for or noteworthy, your work will be noteworthy for? Um, does that have to be tethered to you? Is it just as joyful to see things that absolutely will never have your name on them?
Oh, that's a good question. I mean, I think it probably depends on the mood mood I'm in when you ask me that question.
Right.
Broadly, I think if I'm in my most generous mood, I would say that it's probably very unlikely that I or any individual scientist is going to have some major impact. Most people are putting in small pieces of a puzzle. And all you can hope for is that 100 years from now, we live in a world where health is better and climate is better. And it's because of all of these tiny pieces that came together. That being said, I think you can tell from the fact that I do podcasts and I post on social media and other things that I do love getting credit for things. I love seeing Raman Lab, written on something. I love seeing my name on a paper. So I do get, I think, benefit and joy from people patting me on the back and saying, good job. I think that's a very normal human emotion.
Right.
But broadly, more philosophically, I think as a scientist, it's better to focus on, are you helping the field move forward? Because any one individual, even the ones that are really famous and that we remember, they're just a small part of a bigger piece.
Well, small part or big part, or incredibly scientific or authentically human. I know, Ritu, you're doing work that is catching the attention of so many, and really so grateful that your work is having great impact. Thank you so much for joining me today. This was really a treat, and I hope we can visit with you again down the road.
Yeah, thank you so much. And thanks for all the really thoughtful questions. You made me think about things in a new way today.
You're listening to Trust Me, I Know What I'm Doing. Stay tuned.